better, supported by more data. A is only yeast and water, but B is yeast, water, and sugar. All right? B is yeast, water, and sugar. Raise your hand if you think the sugar has anything to do with the bubbles. Okay. Who can tell me what it is about the experiment that indicates the sugar must have something to do with the bubbles? What is it about the experiment that indicates that, Emily?
Because A doesn't have any sugar and it doesn't bubble, and B has sugar.
Good. A, no sugar, no bubbles. B, sugar, bubbles. Logic would tell you that the sugar must have something to do with the bubbles. Now, does anybody know what the sugar has to do with the bubbles? Anybody want to guess what the sugar has to do with the bubbles? What do you think, Tanner?
The sugar has little air bubbles in it.
Okay, who wants to explain it differently? Emily?
I was gonna say something else.
Okay, Jeremy?
I don't know.
Well, I'm going to write a sentence and see who can fill in the blanks. Do yeast use sugar for blank, 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 blank? It's a four-letter word. Do yeast use sugar for? What would fit, Chase? Food. Okay, how many were going to say food? All right. Yes. Here's another question. Do yeast convert? Anybody know what the word convert means? Give me one word that means convert.
Expand?
Well, no, that could be it. To change. If you convert something, you change it. All right. Do yeast change or convert sugar into a gas? I'm going to have you vote. Think about it now. Do yeast convert sugar into a gas? How many say yes? How many say no? What tells you that the yeast must convert sugar into a gas? What tells you that, Janelle?
Because it makes bubbles.
The bubbles are always a gas. Good thinking. All right, so the answer is yes. 15, last question. Do yeast convert sugar into blank, blank? Yes. This is a gas that has a two-word name. Who can think of a gas that has a two-word name? Mason?
Carbon dioxide.
Carbon dioxide. So yeast give off carbon dioxide when they're in sugar. Who knows of something else in this world that gives off carbon dioxide? Wyatt?
Flowers.
No. Janelle?
Us.
We do. We should have learned that about second or third grade, that people give off carbon dioxide. It's in your breath. There's more of it in your exhale breath than in your inhale breath. Okay, well, here's what we can say. Yeast convert sugar into carbon dioxide. All right. Now, raise your hand if based on the data we've gathered and that conclusion, you think you could repeat this at home. If I lent you the materials, how many of you could do this at home? Okay, I think so. We'll call that a good conclusion because it tells you how to set it. Copy that, and then I'm going to copy something else up here that I want you to put underneath your conclusion after you have your conclusion. Underneath your conclusion, write this word, fermentation. Fermentation. That's what's going on in bottle B. What, Jackie?
You know how we could use this to our parents when we were living in India? I tried to do the egg thing with my parents.
Which one did you try to do?
So when we were surprised, we put the eggs in the salt and the water.
Uh-huh.
My mom, she kind of said it to my brother, and I was trying to explain it to him.
Did it work?
I'll try to do
Okay,
it.
some people try it and it doesn't work because, I don't know if I told you this or not, in every dozen eggs, there are some eggs with different densities. I have to check the egg before I bring my egg focuses to class, because if I had two eggs of two different densities, I'd have two manipulated variables. So you have to do that. Okay, write this underneath your conclusion, fermentation. And then I'm gonna write the chemical reaction that's occurring in bottle B, and I'll explain it after you have it written. That says sugar, and then there's an arrow with yeast above it, and then it says carbon dioxide plus ethyl alcohol, ETHYL. I'll explain those words.
Can we write that?
You write that underneath your conclusion.
What does ETHYL alcohol mean?
ETHYL, that's a kind of alcohol, a lot of different kinds of alcohol, that's one kind. All right, whenever you write a chemical reaction, you put an arrow in it. That indicates that something is happening. And if something is over or under the arrow, that means that's what's making it happen. So the yeasts are making this happen. They convert sugar into carbon dioxide and ethyl alcohol. There are a lot of different kinds of alcohols, and this is just one of them. Only yeast can do this, and they're very valuable to us because they can do this. We use this reaction for two main purposes. One is for making bread rise. Raise your hand if you've ever helped make bread. Did you put it in a warm place to make it rise? All right. Let's say you have a bread pan, and you mix the three main ingredients of bread dough are flour, yeast, and water. Okay. So you mix flour, yeast, and water into a kind of a sticky dough. And if you've mixed it properly, the yeasts are scattered evenly throughout the dough, like that. Okay, then you put it in a warm place, sometimes called a warming oven, something about 100 to 150 degrees, not hot enough to cook it. Yeasts get very productive when they're warm and moist. The moisture comes from the water you put in the dough, and the heat comes from the warming oven. So every one of those little yeasts gives off carbon dioxide bubble. So you leave it in the warming oven until the loaf is the right size and shape that you want it, and it expands because every one of those yeasts form a carbon dioxide bubble. Like that. There are millions of them. The next time you look at a slice of bread, notice that it's about half holes. Have you ever noticed that?
Yeah.
A lot of holes in bread? Everywhere there was a hole, there was a carbon dioxide bubble from a yeast. Okay, then you put it in, when it's the right size and shape, you put it in the regular oven at about 350 degrees, and that solidifies it so you can slice it, and it also kills all the yeast. But don't worry about the yeast, they don't feel any pain, they're very simple, don't feel any pain. So that's one way we take advantage of this fermentation process that yeast can conduct. And almost all countries use yeast to make bread dough rise. You can put other things in it besides the basic wheat or flour, water, and yeast to make various kinds of special breads. Okay, now so we take advantage of their ability to make carbon dioxide, and remember, only yeast do this. All right, now the other thing they do is they make ethyl alcohol, and I don't think I've told you much about alcohol lately or yet in this program, but there are several different kinds of alcohol. One is called methyl. You'll learn all about the different kinds of alcohols when you take chemistry. I'm only going to tell you about three: methyl, ethyl, and isopropyl. Those are just three of the many kinds of alcohol. Methyl is called wood alcohol. And if you've ever been to a banquet or a buffet where they have big food trays sitting over a flame, a flaming candlelight, that was a methyl alcohol burner. It's very inexpensive and they use it to keep food warm. Isopropyl alcohol is called rubbing alcohol. This is called wood alcohol. And this is called rubbing alcohol. And you can buy a bottle of it in any drugstore. And if you've got sore muscles from too much exercise, you put it on the muscles and rub it in and it takes the pain away. Now, ethyl alcohol, they all three are slightly different. Ethyl alcohol is the kind that's in beer and wine. They each make ethyl alcohol. This process is how all alcoholic beverages are made. If you mix yeast with any source of starch or sugar and water, the yeast make ethyl alcohol. Okay, if you mix yeast with grape juice, which has a lot of sugar in it, they make wine. If you mix them with ground up wheat and water, they make beer. If you mix them up with ground up corn and water, they make whiskey. If you mix them with ground up potatoes and water, they make vodka, which is the Russian drink. And if you mix them with ground up rice, they make sake, which is the Japanese national drink. In all cases, it's the same reaction that's occurring. Now, don't go home, please, tonight and tell your parents that I told you how to make beer. I didn't tell you everything you need to know. Oh, I want to tell you something else about these alcohols, though. I'll write them down again: methyl, ethyl, and isopropyl. They all cause they all kill brain cells. They all cause brain damage if you consume too much of them. But ethyl alcohol is the least poisonous. Ethyl alcohol is the kind that's found in beer and wine and whiskey, and of course a lot of people drink beer and wine and whiskey. But all of these destroy brain cells, but ethyl alcohol destroys the fewest. And I'll give you an example. Suppose that a tablespoon of ethyl alcohol, not beer or wine, because beer or wine are only mainly water, but if you have a tablespoon of pure ethyl alcohol, if you drank it, in about 10 minutes you'd be dizzy, and in about 20 minutes you'd pass out, and then after about an hour you'd regain consciousness, okay? But if you drank a tablespoon of methyl or isopropyl alcohol, in about 10 minutes you'd be dizzy, and in about an hour you'd be dead, because they destroy so many more brain cells. Okay, even ethyl alcohol destroys some brain cells, but not as many as the other two kinds. Scientists have done research that shows that people who drink 1 glass of wine a day or 1 can of beer a day tend to live longer than people who don't drink any alcohol. They don't yet know why, but the statistics show that. All right, but if you drink more than 1 glass of wine or 1 can of beer, you start destroying more brain cells. Here's an example. Suppose a can of beer, if a person drinks it, destroys 1,000 brain cells. Well, if they drink another can of beer, it destroys another 1,000. So now they've destroyed 2,000, and they don't get them back. See, this is cumulative. Okay, 3 cans of beer, 3,000, so forth. I know a few people that drink a 6-pack a day. So let's say if my figures are correct, they've destroyed 6,000 brain cells. Well, there are billions of brain cells, so 6,000 is gonna matter too much. But if somebody drinks a 6-pack a day over many years, eventually they'll destroy enough brain cells to make a difference to show signs of brain damage. And the first sign is having difficulty remembering. So a tiny amount of alcohol seems to help people live longer, but a lot of alcohol makes them live a shorter life. But Kendall,
So if they have too much, they could get Alzheimer's when they're older?
well, I don't know, I wouldn't call it Alzheimer's. Nobody understands Alzheimer's completely yet, but Alzheimer's is closely related to, Alzheimer's also involves a loss of memory. What, Jeremy?
Yeah, my neighbor said that, his, grandma, drank, 1 can of beer every single day until she was like 100, I think.
Okay, Janelle?
My dad told me that wine is actually good for you, and that's kind of how I know, because he said that that's healthy if you have at least.
Okay, if he drinks
Wine.
1 glass a day, but if he drinks 3 bottles a day, that wouldn't be good. Okay,
He probably has one.
you have to have all this on your record sheet and all this on your record sheet. Then you're done with this record sheet, and we'll get ready for another focus. The next focus is called the CAPS, C-A-P-S. And get your heading started. While you're doing that, I'll get the focus out. This focus involves 2 jars of clear colorless liquids, A and B. And 2 medicine vial caps, A and B. Here's A and here's B. A and B.